go ahead and get started because I had a difficult time cramming this talk into 45 minutes. I'm Joe Stagner. I work at Zend Technologies. I have been programming for money. I got my first job about 35 years ago, which is a really long time in this industry. It was before the invention of the personal computer, before the cell phone. And along the way, I spent a decade at probably the most notorious software company in the world that you don't generally consider synonymous with open source. And while I was there, I worked abstractly for this really interesting little guy who you probably know by name and face. And I listened to him speak over the course of a decade, and it seemed like every time I saw him speak, he would say, "This is the most interesting time to be a software developer." And I always wondered how, every year it could be the most interesting time. But as somebody who surfed the wave of the dot-com boom, I actually think that we've entered into a really interesting time.
I can't hear you because your microphone's pointing backwards.
So you know that guy, thanks. So you know that guy that I mentioned that was the founder of this big company that I used to work for? I saw him give a presentation at the Moscone Center in California, and he wasn't really well known for being extremely tolerant of things not working. And so he would come in to give a talk, and he would come up on stage, and of course he didn't do rehearsals. He flew in, got in his limo, got on stage, and just sort of expected everything to work. And he was having trouble switching between his PowerPoint deck and the presentation of his laptop. And the AV guy was going to try and help, so he scurried down across the stage to get to the podium where the switches were. And this guy, his name, I won't call him out by name. I'll say his name rhymes with Phil. Phil said, "Hey, you. You only have two things to worry about, the A and the V. How difficult can it be to make those things work?" So anyway, we're going to talk about API Centric Development. And learning new syntax is easy. Changing the way that we approach software problem solving is the more difficult piece. So I often like to start with this quote by Albert Einstein, who said, "The significant problems of today can't be solved with the kinds of thinking that created those problems in the first place." It's not like this is the first time in the industry we've tried to find a better way to do things. And as we adopt new methodologies and new paradigms for building software, we're really always trying to solve the same problems. We're trying to increase developer productivity, trying to increase satisfaction, and decrease the cost of the entire life cycle of our software solutions. So when we talk about API-centric development, we're not changing any of those things. If you've adopted some of these methodologies, not only will API-centric mechanisms still work for you, but if you're doing things like continuous integration, continuous delivery, pair programming, or modular development, all of those things will be accelerated by an adoption of an API-first strategy. So to frame the problem and the opportunity, we'll take a quick walk through history. Anybody ever write code that ran like this? All right, I'm in good and populous company. So we wrote mainframe code, in my case, ran on IBM mainframes and Honeywell mainframes on GCOS, and we wrote applications that ran on 3270 terminals. And computing was very task-oriented. Somebody went to a building where the computer was contained. A computer cost $1 million. And they sat down at the terminal, and they performed a task. And it was usually a task that they were trained to do. They were not only trained to use the hardware, they were trained specifically to use the software. Software was hard to use. It was very task-oriented. Eventually, what was called the personal computer was invented. The technology didn't change that much. We got ASCII instead of just alphanumeric. And the price point for computers had dropped, but it hadn't dropped to the point where everybody owned one. So it was only small and medium businesses and people with larger than average disposable incomes. And it was still a very task-oriented experience to use a computer. You had a home office, or if you had a PC in your home, it was set up someplace, and you went to it to perform certain specific tasks. It was task-oriented. Then GUI operating systems came out, and there were a whole bunch that happened at the same time. So there was Windows, there was OS/2, there was X Windows for lower-end systems. Atari had the ST series, which had a GUI operating system. Commodore had the Amiga. And as a software developer, there was sort of a benefit in that Windows had almost complete domination of the marketplace, 99%. So the price of computers had started to drop and became more and more accessible, but really we could write an application once using the Windows SDK, and that application was available to 99% of the marketplace, which is pretty much all we cared about. The other 1% wasn't big enough to matter. And the kinds of tasks that we used computers for had moved away from the sort of mundane business-oriented things to things that we might choose to do, not that we had to do. And then in the late 1990s, there was a big move towards what we called web applications that we now look back at and think, yeah, we were just using the web browser as a dumb terminal, and they weren't really applications, it was all server-side. But there are two models for this. One was for companies that wanted access to customers that were outside their immediate geography, but the bigger adoption was driven by enterprises who wanted to deploy web applications inside their enterprises to decrease operational costs. I did some consulting for a large insurance company that had about 5,000 employees and about 30 apps that those employees used. And they estimated that using their Windows PCs, every time that they made a change to any one of those applications, the desktop deployment fees reached $250,000. So the opportunity for them to drastically reduce their IT operations costs by moving to web-based applications was very exciting to the managers and particularly the CFO. And it took them 2 or 3 years to find out that they actually didn't end up saving all that much money because the productivity dropped so much because of the difference in how the desktop app worked versus how the web apps worked. But by then, they were already committed and they started looking at how to solve that problem. Now, along the same timeline was the evolution of the cell phone. Motorola had a cell phone in 1980. They just didn't know how to make it in a way that it was affordable to the general public. So over the course of that same timeline, cell phones became cheaper and started to get more widespread adoption. Also along this time frame, the personal media player happened. So it started with music players, MP3 players, and then Apple came up with a clever idea and said, hey, why don't we add some functionality to this personal media device that we're shipping? So the second or third generation iPods came out. They ran software applications that played videos, that showed you pictures, that had some simple games. And along the same timeline, towards the end of the spectrum, there were companies like RIM and BlackBerry and Palm that were trying to figure out how to move that technology towards personal computing devices. But the real home run was when somebody at Apple said, hey, we've got this media device that's really popular. And it's about the same size as a cell phone. What if we tried to put those two things together? And, well, we all know what happened. Right, so what we have now is, this stat's 2 years old, there were 6 billion active cell phone subscribers, and almost a billion of the devices sold in 2011 were smartphones. That's a huge market, especially when you consider that at the same time frame there were only 7.2 billion people on the planet, but there were 6 billion active cell phone subscribers. That's a huge marketplace. But for developers, it created a pretty profound problem. There's no longer one dominant platform. We can't force users to choose the hardware that we choose to support in our software development efforts. We've got all of these different devices, and there's no clear winner. So Android is clearly number one in the phone marketplace, but iPhone is certainly statistically significant. There are more iPads than other tablets, although that trend is reversing. Right? So there's a pretty even split there in terms of our prospective customer base, and we really need to support both. And then beneath them, we have companies like Microsoft with lots of money that wants to be important in that space. We still have the BlackBerry, and we've got startups like the Ubuntu Phone Project and Firefox OS from Mozilla. So there are a lot of players in that space. If you look at that collection of devices, there are not only phones and tablets, but there's some other kinds of devices that are creeping in. There's a smart watch there that I actually saw one a couple of weeks ago at a conference. There's a GPS that actually runs an operating system. And more than that, we're going to talk about the technology that's feeding this API-oriented development. But if you think about it, everything can connect to the internet now. My car connects to the internet. My refrigerator can connect to the internet. The security system in my home, the environmental control system in my building, and even more granular things. There's a door lock now that speaks HTTP. You can get lights for your home that speak HTTP. And so what that means is that as software developers, the opportunity for the work product that we produce goes far beyond personal computing devices. And we're left trying to figure out, what do we do? How do we service as many prospective customers as possible without having to write the same application over and over and over again? 6 billion. I get stuck on that number. So how many of you own your own company? Some. I was a serial startup guy before I went to Microsoft. I went to Microsoft after running a company in New York, and I had offers from IBM and Microsoft, and I thought Microsoft was way more screwed up, so it would be a more fun place to work. And I got stuck there for a decade. How many of you have financial responsibility for the apps that you write? Right? A few said yes. I'd suggest that we all do, right? Because if our apps aren't successful from a financial perspective, and whatever that means, then we probably don't stay in role. Let's look at adoption curves. We're going to talk about what this opportunity really means. Right? So from the time the radio was introduced, it took 38 years to get to 50 million users adopted. By the time the TV came out, it only took 13 years to get to 50 million. By the time the internet came out, it only took 4 years to get to 50 million users. Let's look at one case study. This little app called Draw Something. It's available on the iPhone store and the Android store. And guess how long it took to get to 50 million users? 50 days. Right? So think about the numbers. That's 1 million new user acquisitions a day, every day for 50 days. And who knows what the long-tail revenue of that was. And if I could tell my CFO how to acquire a new million users every single day for 50 days in a row, I could retire. That's a massive opportunity. But I think it's not just the technology that's created, the device technology that's creating this perfect storm of opportunity for developers. A couple other things that have happened at the same time that combine to make the opportunity, and one is the nearly ubiquitous availability of high-speed wireless internet access. So this is a coverage map for the United States. Europe looks the same. And one of the interesting things is, before I worked at Zend, I worked for Mozilla, and I was involved in the HTML5 ecosystem and did some work on the Firefox OS project. And we looked at places like Africa and Latin America as emerging markets where we would launch those devices. And one of the interesting things that I discovered is that there are entire geographies that skipped the hardwired connection to the internet and went straight to high-speed mobile infrastructures. So for example, there are areas in Africa that have better cell phone coverage and better high-speed internet access over wireless than we have in lots of the United States. So those emerging markets all of a sudden become really important to us as software developers. The other thing that's happened at the same time is this concept of cloud computing, where I, as an entrepreneur who starts a small company or even a single developer, I can build my app, deploy it in the cloud, and pay only for the resources that my app consumes. And then if next month my app gets featured on Good Morning America and I have this monster 1,000-fold spike, my app can scale because of its existence in the cloud. And then when that spike reduces back down to some normal standard level, I don't have to keep paying for that peak level of computing power. I go back to paying for only what my app is using at the time. And that makes the launch process affordable even for an individual. Last year at AppDev in London, I met a guy who was a software developer. His company said, hey, we need a mobile app. I think he started with Android. And to teach himself how to program Android apps, he made a little app that basically all it did was show quotes. He was an English lit major in school, and so he had collected these quotes over the years. And when I met him, that little weekend project app was giving him the opportunity to cash a check every month for about $60,000, which was a pretty good little part-time income. He still kept his regular day job. And so, even a one-man shop. So, if you think like that, then that perfect storm looks more like a yeehaw opportunity. So, from a technical perspective, I'm a PHP guy. This stat shows you 78.6% of the World Wide Web is run on PHP apps. Drupal is built with PHP, Joomla, WordPress. It's why I went to work at Zend, because I'm a PHP guy. But the kinds of technologies that we're going to be talking about are based on open standards, which means that if you're a Ruby guy or you're a Python guy, and that's what you want to develop in, I can write federated logic in my language of choice. You can write it in your language of choice, and we can very easily communicate. I'm sure you already know, but this is just a statistic. We do a big developer survey, stats every year, and our developers have told us that 91% of them are working on mobile solutions, and that's up from 66% only a year earlier. So companies are really starting to get that they have to play in the mobile space. These other stats are interesting too, that almost 3/4 are telling us that they're using cloud-based APIs in some fashion. So what's the problem that we're trying to solve? So what I see time and time again with customers is that they have an app, maybe they even have two apps, a desktop app and a web app, and now they're needing to support additional customer platforms. And what far too often happens is that code gets moved. Now, sometimes it's because the platform is different. So if I want to, if I have a Windows app, it's probably written in VB or C#. If I have a web app, you know, who knows what it's written in. And then I need an iPhone app, for example. Well, that has to be Objective-C. Now, maybe later we'll talk about why it doesn't necessarily have to be Objective-C, but historically speaking, that's the choice that was made in the beginning. Now, Android starts to get popular. My company needs an Android app because our customers are telling us is lots of them don't have iPhones, they have Android apps. Android is a Java stack. And what often happens is, because it's a different language, all of the logic, a lot of it, which is common between implementations of our application model, gets moved from one platform to the next. And a lot of times that even happens because, hey, we need an Android app yesterday, we don't have Java developers on staff, so we're going to outsource this to get it launched, and then we're going to take it back in-house. And what we end up with is these siloed applications that all implement different versions of the same kinds of logic. Right? So the height of code reuse becomes a cut and paste strategy, which we know is a bad idea. Because it means every time we find a bug that needs to be fixed, we need to implement that change in code every place that we've implemented that logic. And worse yet, every time we have a new feature, it's going to take us maybe as much as 4 times as long to implement it in every one of the platforms that we need to support. This just it's not a fiscally responsible way to run software development. It's not sustainable over time. And there's another problem. And that problem is that the expectation of app users today is that they're going to get a certain kind of feature, and often those features just can't be, it's just not economically sound for us to integrate those applications from scratch. So for example, when I worked at Microsoft, we were building Virtual Earth and live maps, and Microsoft spent hundreds, literally hundreds of millions of dollars just to acquire the maps and the geocoding data behind this. So if I'm Starbucks and I want to build an app for cell phones where I can say, hey, I need my caffeine fix. Bing, show me where the nearest Starbucks is. That's a feature that my customers, if I'm Starbucks, are really going to want, but I can't spend $250 million to acquire the data to power that, right? So the only economically viable way for me to do that is to select a service that's their core competency, that's what they do for a living, and pay for that service, and to access that service and surface it in my app through an API. So the post-industrial revolution produced a phenomenon that I think has gone understated, and it makes for a great analogy to what we want to do with API-oriented software, and that is the integrated circuit. Right? So everybody's seen these. Any of you actually played with hardware, building your own boards and stuff? So the interesting thing about this particular chip has a 14-pin interface, and it goes on a board with other components, and it fits in that 14-pin socket, and the other components on the board only know 2 things about it: how to format the stuff that gets sent to it, and how to unformat the stuff that gets returned from it. But other than that, the other components on the board don't know anything about it. So if I discover a defect in the programming that's in that chip, or just want to improve it, I can change how that chip does what it does to my heart's content, as long as it speaks the same input and output formats and fits in that 14-pin socket. The rest of the ecosystem on that board doesn't care at all how it does what it does. So I can create a brand new chip, as long as it has the same IOs and fits in that 14-pin socket, pull the old one out, put the new one in. The rest of the ecosystem is none the wiser, but the overall experience of my electronic device increases. And we can look at API-centered software development the exact same way. Here's what we're going to try and get to. Right? So the idea here is that each one of the platforms that we need to support has only this platform-specific code that's required for that platform. Right? So sometimes, for example, maybe my phone has a GPS in it. So it can, at any given point in time, give me longitude and latitude, but my tablet doesn't. My tablet has to use an IP address locator. Now, it still gives me geoinformation, right? But the code that figures that out, how to get that from the device, might be different on each device. Everything that's common, we want to put in an API layer. Now, certainly there are some considerations about this. The API needs to be called, and the first thing people go is, yeah, but that can't be very performant, especially in cell phone infrastructures. Doesn't mean it has to be called every single time, right? So things like static assets or media files can be downloaded once and cached. Even logic can be downloaded. So I worked recently with a company that had implemented this model, and they had a rules engine in their business logic layer, but they wanted their app to be able to run offline. So what they built in their business logic layer was a versioning system by which when the device connected, the device asked the business logic layer, hey, I'm using version 11 of the rules engine, is there an update? And the answer would be yes or no. And if it was no, it would use the one that was cached locally, and it was actually code. And if the answer was yes, then it would say that the business logic layer would push the new version of the rules engine down to the client, and the client was up to date and could run online or offline. Does that make sense? Now, there is a problem, though, and I was talking with somebody earlier about my time at Microsoft. I worked in the .NET group, and I used to tell the guys on my team that while it was brilliant, some of the stuff that they were doing, we were creating an entire generation of web developers that didn't understand anything about how the World Wide Web works. So if you're a PHP developer or Python developer, that's probably not true. But there are a lot of developers who have never had to delve into the mechanics of how TCP/IP works, how HTTP works, and we need to do some of that in order to create effective APIs. So there's all kinds of technology that's been implemented to make one piece of software talk to another piece of software, and customers I talk to are often find it really daunting to look at all these acronyms and say, how do I get started, even with the new wave? So my advice is just start with the most popular. Pick the ones that seem to be growing the fastest and use them unless there is a use case for your specific scenario that disqualifies them. Then look at the other ones. Okay? We're talking about HTTP. Virtually everything speaks HTTP. It's what I call the lingua franca of the World Wide Web. Everything speaks HTTP. JSON is just a way to package data. Right? And we'll take a look at different options, but JSON is really easy. And JSON, how many folks are using JSON already? Awesome. So it stands for JavaScript object notation, but I think we should stop thinking of it as that and start thinking of it as an acronym for, like, I don't know, just some object notation, because it really doesn't depend on JavaScript. Right? There are libraries in virtually every modern development environment that can parse and I/O JSON. REST is one that's a little bit more controversial. So representational state transfer depends on using the HTTP verbs. So you can do endpoint-driven web services like this, right? So I've got a URL in my app, and then I can call specific methods. So I call insert, that's a specific method. Or I can, tag parameters on my URL, et cetera. And there are some times when you might have to do that, but it starts to get really complex when you're using multiple verbs, and especially when you start to pass more than trivial data. So you have to populate the body. So I recommend that you look at REST as the preferred mechanism. This is curl syntax for get versus post requests, and you notice both requests are going to the exact same URL. So my code picks up the HTTP headers and says, oh, if it's a get, that means return something, in this case, a customer record. Right? If it's a post, then I also want to look for the data that was sent to me, and I know to store that. Not only can you use the standard HTTP verbs, but you can use custom HTTP verbs, and in PHP it's really easy to add verbs to the headers. when you look at the difference between JSON and XML, so there are some times when XML is the right choice, but my suggestion is that you use JSON as the default unless there's a use case to the contrary. So a couple of nice things about JSON. First of all, we're developers and that looks like a data structure because it is a data structure. The other thing is that if you think about the difference between the XML version of this record and the JSON version of this record, this is pretty generic in terms of how I will start dealing with it programmatically. The XML version is not, really. So what that means is that I can write code that can take this in and start to do stuff with it without knowing the specific syntax of the data that I'm going to receive. But in the case of the XML, I have to parse that XML to get the key value pairs into a data structure. And in order to do that, I need to know that their name is car, company, name, price, etc. Right? So it's a little bit more complex and it's a little bit more tightly coupled. And we want to use loosely coupled strategies whenever we can. Does that make sense? Any questions at this point? All right. So one of the things maybe you're thinking is, yeah, that's great if I'm starting from scratch, but what if I already have applications? I work on maintaining and enhancing existing applications. No problem. We see this far more than net new applications development. And the way to get started is by starting to implement an API layer, right? And then if you build new stuff, of course, build that app on top of the API layer. But then in your existing applications, start to pair off low-hanging fruit. Grab pieces of functionality that can be abstracted out of that silo of application and start to call the API layer. And you do that one piece at a time. There's still that static dependency and you still get code duplication, but you're starting to improve the process. And eventually, you've abstracted all the commonality out of those silos and into the API layer. So you just do it one piece at a time. And ultimately, you'll end up with the ideal architecture which federates as much as possible into that API layer. So what do we get when we're done? So one of the interesting things about the web is we've been talking about client-server since the dawn of the World Wide Web, and it's only been since the Ajax phenomenon started a few years ago that we've ever actually started to leverage the computing power on the consuming device. Right? If we do API architecture right, we get to federate our logic in a very flexible way and maximize the computing power wherever it happens to be, and it's usually not on the consumer's device. We get real separation of concerns. Right, so as a rule of thumb, we want to implement APIs that are atomic in nature. They want to be as single task as oriented. We don't want one API that has like 700 different methods. We want an API for each thing that we want to accomplish. And that makes them loosely coupled. It eliminates the dependency between all of the APIs combined. We can also add features without touching the adjacent code. If we need to make changes, it makes our whole testing process much easier because we only have to really feature test the one API that we're working on, and then we run automated regression testing just to make sure we didn't break anything else. But it's much more uniform. Endpoints are eminently testable for that reason, so API-driven development is uniquely suited to facilitate continuous integration efforts. How many folks do continuous integration? Run full-time builds? Awesome, awesome. Zend is working on a bunch of continuous delivery and continuous integration stuff. So if you go to the Zend site and you look, you'll see we're adding all kinds of plugins for Zend Server to support the CI and CD efforts. Stateless endpoints are innately scalable. So the cool thing about stateless endpoints, meaning a URL that executes some logic and the entire context is received in the request, means that I can scale that out horizontally as much as I want. I don't have to worry about making sure that requests get back to the same physical server as the session was originated on. Just makes scalability much easier. And HTTP ubiquity means maximum code reuse. So if I have a particular function, right, and that function is accessed through a URL, it can be accessed from my tablet. That same URL that offers the same function can be accessed from my furnace or my refrigerator as long as it's speaking HTTP. Another thing that we experience at Zend is that your teams can be much more federated. So because our development efforts are organized in a more atomic way, each API has a specific set of functionality that it provides, your teams can spread out. How many of you work on geographically dispersed teams? Awesome. A lot of companies are hesitant to get started that way. Zend is completely geo-distributed. The Zend server team is in Tel Aviv, Israel. Most of the studio engineering resources are in Dublin, but we have contributors, and the Zend framework guys are spread out all over the place. So let's look at a little bit of code, and I want to show you something that the Zend framework team has built that's free open source that will help you with generating APIs. So just for a little context, right? How many folks have written code that actually parsed HTML to get data? Yeah, it kind of stinks, right? But it's we do those jQuery calls where we say find me all of the things that are of this class, and then we iterate through them, and we really have to extract data to create a programmatically accessible structure. That's not a great way to go. And so the next step was to go with XML, but we've looked at the dependencies there. JSON is where we really want to be, right? And one of the cool things about working with JSON, by the way, is if you work with modern browsers, Firefox or Chrome, working with HTTP and JSON data gets really easy. So you can do command line HTTP requests with curl. How many folks use curl on the command line to test and prototype stuff? Awesome. And the other thing is that both Firefox and Chrome have browsers that are very JSON aware. So, for example, JSON doesn't actually come with formatting. So what's being received is actually just this JSON in the form of a text. But this JSON view plugin for Firefox formats it, gives me the object models, and shows me all of the key value pairs. Right? So from a day-to-day work perspective, we have a lot of tools that make things easier for us. Now, if you're a PHP developer, you can just return the JSON, right? It's just a stream, right? Probably don't want to hard code a whole lot of JSON, but the point here is that there's nothing special about how it moves back and forth over the wire. And in PHP and in other languages as well, there's really straightforward ways to package JSON. So in this case, I create a PHP array called JSON encode, and now this data contains JSON. This variable contains JSON data, and echo it out. Decoding, similar, one step. And once I've decoded it, there are, in PHP, and I'm sure in other languages as well, there are built-in methods that allow you to change data format. So in this case, just moving from an array to a string collection. And it means the same data can appear inside our program in very different ways, whichever way is most expedient for us to program against. Now, let's look at just a little bit more practical code sample on how to actually call one of those services. Right? So we've said that in PHP we can use the built-in methods to turn data, object arrays, into formatted JSON and return it over HTTP just like we return a web page. Here in this snippet of code, we're looking at how we actually can call that web service and work with the JSON data that's returned. Now, in PHP, there are three popular ways to make endpoint calls over HTTP. One is to use file streams, which I prefer not to do because I think it sort of mixes metaphors. The other is to use the PECL HTTP extension, which is much more object-oriented in feel. So lots of folks use that, and I like it. One caveat is if your apps are deployed in shared hosting environments, it doesn't always exist. The other is to use curl, and curl, as you can see here, is a little bit more verbose. I generally prefer to use curl, though, because curl gives me a very detailed access to all of the header information. And the other thing I like about curl is that I can test on the command line and then use basically the same commands that I prototype on the command line in my PHP code, because the syntax is pretty much the same. So here I'm just setting up this array of curl arguments, calling the URL, sending a sample user agent, right? So this could say, pretend I'm Firefox or Chrome. Executing that curl call. Then I want to clean up after myself, so I close curl. What I have in response is JSON that I'm going to decode, and then decode it into an array. I just iterate through that array, and I display all the elements of data. So let's this is the app running. So what you see here is that I got multiple records in that JSON collection and just iterated through them in a for loop. Right? So at this level, fairly simple. Any questions or comments? So at this level, it's pretty simple, and but I don't want to give you a false impression that API-oriented development is trivial. So there are lots of things. The more that we want to make our APIs service a wide variety of clients, the more complex things start to get. So we start to add things like, one of the big ones is content negotiation, right? So in the case where I'm writing both the server side and the client side, I can pretty much say, this is what I'm going to receive as input, and this is the way I'm going to send the output, and everybody has to comply with my way of doing things or it's just not going to work. But in real world, that doesn't always happen, especially if the service that you provide, that, the web service, the API is your product. You need to service as many different clients as want to come to you, and they can't necessarily be forced to use the mechanisms that you want to use in place. So one of the things that gets complicated is content negotiation. This is done through HTTP headers, but there's an exchange that takes place between the client and server that says, hey, this is what I will accept, these 6 formats, and here is the order of preference in which I'd like to get them. So I'd rather have JSON, but if you can't send me JSON, you can send me plain old XML. And if you can't send me plain old XML, I'd rather have that, but I'll take plain text. So that content negotiation piece can get complicated. Authentication and authorization can be a little complicated too. And another thing that can be a mess is versioning. So at Zend, Zend is an interesting company. We have commercial products, but we are based on open source technology, and about half of our engineering resources work full-time on free open source products that really don't have anything to do with the way that Zend makes money. One of those is called Zend Framework. How many folks use Zend Framework in some of their apps? Great. So the Zend Framework guys got hijacked a couple of months ago, and we asked them to build a set of technologies for developers to help them get accelerated in starting to do API Centric Development. So what was produced is this thing called App Agility, and you can find it at appagility.org. This is what it looks like. Right now I'm running this on the built-in PHP server in PHP 5.4 because it's for 2 reasons. First of all, because it's really alpha. Technically, it will work on Apache, but you actually don't want to run development tools on the same web server that you deploy production code. So from my perspective, it's a good idea to run it off the command line server. And just really quickly here, I'm going to walk through a couple of pieces. We've got 5 minutes. So generally speaking, there's got to be some source. So the API is going to get called, and there may be some discretionary logic in the middle, but we're going to get something from somewhere and deliver it. Right, so we start with this concept of data adapters, and creating one is really easy. I just create a name, specify the driver type. Right, so you can see that there are tons here that are represented already. I'll pick PDO SQLite. The database name. Now in this case, it's going to be we're actually going to point to a living database. So. Now, I will tell you, when you start playing with this, this is really alpha software, so there's a lot of the secondary code that's not in there yet. So, for example, if you choose a SQLite database that doesn't exist, or you pick a table name that doesn't exist, you don't get an error message, your app just doesn't work. We'll get all that fixed by the time we get to release. So here I can specify authentication credentials for my database if I need them, etc. Create the DB adapter. I can edit the specifics. And then I can say, let's create an API. Right. That creates a shell for an API. And then we can say, now, I talked about preferring REST services. One of the things that you'll see is App Agility is a very opinionated framework, so the team has done research on, and made declarations in terms of what they think is the right way to do things, with an understanding that maybe that's not going to work for you for some reason. So while REST is the preferred mechanism, we support RPC services as well. I'm going to say create a new REST service. It's going to be DB connected. I'm going to choose a data source. I got to specify the name of the table that I want this service to run against. Now, just for reference, this is the table that I'm running against. It's a SQLite database. And I have this session table. And this is just a pull from our joined-in data for ZenCon, which happened a couple weeks ago. So you can see all of these sessions. Here's the first one, the opening keynote. So I can go into this API that's been generated, this user interface, and I can say I want to edit it. So the first thing is I don't want it to be in the root, so the root of my application, so I'll put my APIs at their own endpoint. There's automatic paging built in, which can be very tedious to implement, so we can specify what we want the page size to be. We can specify which HTTP verbs we want to support, so this is going to be read-only. As you can see here, there are lots of different options. Because of time, I'm not going to go into them. And I could say generate, and I have this API. So if we look at an API, and I'm going against a version of this that I built last night just to make sure I haven't introduced any uncaught errors. Now, notice what this is trying to do is the browser says, I don't know how to handle HAL-JSON, which is the HTTP type header that we sent. But luckily, there's a plugin for Firefox which lets me make HTTP requests to JSON. So it tells us 200 OK was the status, and this is what we got in return. Right? So notice there's a ton of data here, but you'll notice this is the first of the records that was in the database that I showed you. Now, some of the cool stuff that's built in, if I want to go to a specific session, I can just append the session number, right? Because we get clean URLs as part of our REST implementation strategy, and now I get just that one session. As I mentioned, paging is also built in, so I can specify a specific page that I want. And again, what I'm really getting here, I'm just getting the JSON return. This is just that this REST client plugin for Firefox does some formatting for me. Right? But this is a REST data object that I can iterate just like I showed you the simple example of in the PHP code. So again, this is called App Agility. You can find it at appagility.org. And it's a great way to sort of jumpstart your API development using best practices. Yes?
Is that generating code that I can then manipulate, or is it all built through the tools and that sort of thing?
So that's a great question. The question is this generating code that I can then manipulate, or is all built through the tools? So it's absolutely generating code. You have your choice. You can take that generated code and just pull it into whatever you want, or you can generate directly against the data structure that you want to move to QA and then to production. The upside of doing that is that there's a versioning mechanism. So, you know, one of the models for versioning is that you can change the implementation, but you can't change the signature. Right? So if we needed to change the signature, we could say, hey, let's just create a new version. I've only got one version. I'll create version number 2. And the routing system that's part of App Agility works with that helps you maintain the various endpoints that you need. And just for fun, we wrote a little app. This is an app that uses that data. This is based on it's using the AngularJS framework. And if we look at the code that it uses, this is the HTML. It's less than a page of markup. Actually, this is the HTML for the page itself. This is the template for displaying the sessions, and there's really not that much code required to call that API and and populate the data structures that get displayed. So it's pretty straightforward. But you can move the whole thing. You know, you can pick up that code and move it all to someplace else, or you can deploy right from the directory structure that AppAgility creates the services in. Yes?
Can you specify headers in AppAgility?
Yeah. So the question is, can you specify headers? And yeah, some of the stuff that I scroll by, some of the features there, you can put, accept headers and basically anything that you want. And it's all PHP code, so of course you can, anything that you can't do through the API, you can do manually. Sir? Yeah?
What about the logic that you're building to create the service?
Well, so obviously what you're getting here is the shell based on the information that can be reflected upon, but it's all code. So there are stubs where you'll add your own application-specific logic.
I can get access to that code and bring it and build whatever I want to.
Oh, absolutely. So this is.
Change how it automatically builds the code.
Can you change how it automatically builds the code?
You've got logic that's building the service. Can I get in there and hook into that and say, when you build it, I want you to add this?
Absolutely. So the question is, can I go in and change actually the way that the code gets generated? So first of all, AppAgility is all open source, and secondly, it's built on top of Zend Framework 2. So you'll notice that we use this without any understanding of Zend Framework. But but especially if you're a Zend Framework guy, you can go as deep into the guts to change the way that the code gets generated. Some of it can be done through the UI. Other parts can be done in the templates that are used, and then anything that can't be, if you should get to a level of granularity that neither of those two layers can solve, you can get down into the Zend Framework code and do it yourself. Any other questions? All right, you can reach me at joe@zend.com. Thanks for coming, and please feel free to email me. Where?